Are we streaming? Okay, hi. Hi, everyone. Welcome to this meeting of the Warren Astronomical Society. We are live and hybrid at Cranbrook Institute of Science. I'm your president, Bob Tremblay. Tonight, our short talk is going to be a short history of Stargate Observatory by Dale Teamy. Our main talk will be The Way We Found the Universe by Jim Shedlowsky. So do we have any first-timers tonight? I know we have some of Dale's students. Hi there. So yeah, some of Dale Parton's students are here tonight. So if you don't know, I guess you guys tried to go to Stargate, but you got rained out the last time you tried that. So we also meet the third Thursday at Macomb Community College South, which is next week. It's one of those odd things, the odd months. So we have a whole bunch of volunteer speakers. You probably already know that. Let's see. And you can watch our previous meetings on YouTube if you want to binge watch some really cool episodes. So you can renew your membership with this fellow down here. During the snack break, we members get a really cool name badge. And so let's see. So roll call. We like to go through the ranks and give a roll call of who's here. I'm Bob Tremblay, president.
Dale Teamy, editor. Dana Bransky, treasurer. Ed Schwartz, Bob Berta. Zensky. Edward. Jeff McLeod, outreach. Jim Shedlowsky. Dale Parton, first vice president. Laura, Mike Bernard. Joanne. Great. 20 silos.
Hurry and move now.
Hey, Bill.
You don't want a car carry number.
All right. Hi, guys. All right. We heard from Gary Ross about the passing of Gerald Jerry Persha, a member who moved to New Mexico after creating an astronomical optics business called Optics over by Grand Rapids. He rejoined our club remotely in 2023 and contributed several articles to our newsletter. A memorial page will be in our October newsletter. Wasp wearables, shirts, whatever, are available from Mark Gedzier. There you can see what's available in our newsletter. Wasp stickers are available from David down here. Astronomy at the Beach. This is our big event, and it is coming up 26th and 27th out at Island Lake State Park. We're expecting a lot of people this year. We'll have a table under the club tent, and Brother Guy has asked me to help out at the VOF tent, so I'm going to try to get those two positioned right next to each other. What? I did.
Okay, because
I'll-
the sheet I saw, they were very far apart.
Oh, really? I'll talk to him again. So, Astronomy at the Beach is hosted by the Great Lakes Association of Astronomy Clubs, which this club is a member of. They meet every second Tuesday, which is tomorrow. So if you're interested in seeing the last meeting or attending the last meeting before Astronomy at the Beach and helping out, that will be tomorrow. GLAC would like GLAC member clubs. There's like 7 or 8 astronomy clubs around the area, and they would all like to share speakers between them. So if you have given a lecture here, you can give it to one of the other clubs, and they would like that. So talk to them. Okay, the picnic was fun, but lightly attended. I would have liked to have more people there, so hopefully we'll have more people next year. Elections are coming up in November. That is 2 months. A couple board members are term limited out of their positions. So, and board memberships now get a free membership. Board members now get a free membership. So, not yet.
Approved by the membership.
Oh, do I have to do?
This is you notifying.
Oh.
Voting.
Oh, okay. I'm sorry. Robert's Rules of Order. I'm not. I'm sorry. Okay, so we want to do that now? Why not?
No, because we need the verbiage to change the bylaw.
Oh, so we're gonna do that probably at the election.
Yeah.
Okay. So kick the bucket down the road. Okay, astrophoto calendars, we need your picks. We need your picks. Guess who's gonna be president next year?
Yes, Bob, what vacancies are there?
What vacancies are there? Well, first of all, president, first vice president,
Treasurer?
that it? I think that's it.
So,
Okay, so that is 4 positions we need people for. Now, as has been done in the past, people could juggle positions, but I'm not taking the treasurer position. I don't want to be irresponsible with other people's money. So anyway, astrophoto calendars. We have a astrophoto calendar every year. If you've taken an astrophoto that is really cool, we could use it. Send it to publications@warrenastro.org. I would like to see our discussion group start back up because that was something we were doing back before COVID. This month is probably a little busy at the end of the month, but probably the 4th week in October. If you're interested in hosting a discussion group at your place of work, if they'll let you or your residents or what have you, let the board know and we'll get an announcement out and you'll have people come over and talk about astronomy and stuff. Okay, September is the month that the NASA Solar System Ambassador programs look for new candidates. If you're interested in being a Solar System Ambassador, I can send your information to them. They like actually having ambassadors recommend people. Our next meeting here in October, we are going to be providing pizza. Yeah, no, that's not good. So, the question is, do we want to have members bring something? It's not necessary, but if you'd like to bring something to pass, that would be fine. But we will be having pizza here. I have a poster at home that says "Pizza, Nature's Perfect Food," and it's got a picture of pizza with lines and arrows. I really do have that poster. So, Dale, what is going on with presentations? I've promised you like 6 of them so far, haven't I?
Yes.
Yes, I have.
Okay, so at our next meeting at Macomb, September 18, which I think is next week,
Yeah, next week.
our main speaker will be Diane Hall. Her topic, Spark of a New Sun, a visit to Kali Crater, which I think is in Estonia. So there's a story she's going to tell about that. Then, as Bob mentioned, a week from now, we're going to have a pizza party, and Jeff McLeod is going to have an astronomy exam for us. Or if that's scary, we'll call it an astronomy quiz.
Would it be great?
Yeah, the amount of pizza you get will depend on your answer. So that's what's coming up. And as Bob said, the plan is to have pizza and pop. If some people would like to bring some kind of a side dish, you're welcome to do so. It's not required. Thanks, Bob.
All right.
And I need more speakers.
He needs more speakers. He always needs speakers, especially the short ones, which I've promised a bunch already. All right, Riyadh, what is going on with the observatory? Holy mackerel, you are all red, man.
Lighting is a problem.
Lighting.
Yeah, well, thanks. Hello, everyone. So we opened the observatory at the last open house on August 23rd, kind of in the beginning of our picnic. But the sky was kind of partly cloudy or mostly cloudy and kind of stayed that way until it started raining really hard after the picnic ended. We kind of huddled at the inside the observatory for a while, and then started to clear up around 10:30, and that's when we got actually the the 10-inch Dob outside, and we still had a chance to look at some deep sky objects, some double stars, and we looked at Saturn. So we still got some observing done. Jeff McLeod also brought his Gemini space capsule simulator, and that's always very popular. People lined up and got inside it, of course, and had their trip to the moon or around the Earth. All kinds of things were going on. It's always a lot of fun. So we stayed there until about a little after 12, when pretty much everybody left, and we closed the observatory at that point. Next open house is going to be on Saturday, September 27th. So that's during the astronomy at the beach. But this gives us 2 locations. So in case somebody can't make it to astronomy at the beach, the observatory will be open, depending on, of course, on the weather. If it's cloudy, it'll be open for a couple hours. If it's clear, as long as people show up, we'll be there for a while. So hope to see you then. Thanks.
Thanks, Riyadh. David, what is going on with Treasury?
Okay, so the treasury, we have in our checking account $22,218. There's nothing due on our credit cards, so yay. PayPal, we've got about $524 there. Our cash box, before I paid out Dale, we had about $204 in there, and I understand we owe Mark some money. Also, we want to thank Mark and also everybody for bringing in foods for the picnic. So thank you, and thank you for your graciousness of doing that. That's it.
All right, thanks. Charlie,
Yes.
what is going on, Secretary? I just saw an email about the metro parks too.
Yeah.
All right, not a whole lot going on from the secretary's office here, but we have last month's meeting notes can be found in this month's issue of the WASP. And some name tags are available. Check with me to see if yours are available or if we need to make yours. And if you don't have one and would like one, please don't hesitate to email me at secretary@warrenastro.org. And also, we've been having ongoing correspondence with the Metro Parks about Stargate. And we're focusing on improving the concrete around the building there since it's deteriorating.
And they replaced it with very trip-worthy rocks.
And with long-term investigation right now into improving Stargate into a educational and warming center. So that's what we're looking at here.
All right. Thank you. All right. So, Jeff, what's going on with outreach? My wife and I did something out at my daughter's.
I got it in my notes. Put me up on the big screen. But let me get my notes out. Yes, it's a paper plate.
Here you go.
You know, sometimes you just have to make do with what you got. Okay, the big news is we have a driver to get the big Dob to astronomy at the beach. I confirmed with Greg, he's down, so it's all good. The week of, we'll coordinate, get it all loaded up. Did Riyadh talk about the Dob? No. So Mark Head's here right there. The man with the plan. Got the upper, the new mounts for the truss tubes installed on the big Dob. It is a huge upgrade. It's going to make things a lot easier. Still need to do the bottom post astronomy at the beach, but the bottom What about the fork? It's all done?
Not forks, but the focus.
Yeah.
Two legs are all.
Oh, I want those forks. They're gonna be so nice. But yes, this is like more than a year in the making at this point. So
Yeah.
this is cool stuff. Very glad that Craig said he was gonna drive, otherwise we'd be in trouble. Bob and Connie did some moon viewing somewhere.
Out Algonac, my daughter's trailer park, and we had about 35 people there, several adults as old as me who'd never looked through a telescope before.
What was the date?
Got last Saturday.
Okay. I'll
August.
email you and try to get it in my thing. Can you pull that link up?
Which?
The Michigan Coolest something. So for those that aren't familiar, Planewave, the big kind of local telescope maker in Michigan,
Is it?
they have requested that we help them win
Oh, for crying out loud.
another year of the coolest thing made in Michigan.
There, this link.
I just clicked on that. So if you Google MichiganCoolestThing.org, you'll probably find this website, and you don't have to just vote for what I tell you to vote for. You can look through the things, but
I'm putting it in chat right now.
don't you want something from astronomy to win Michigan's coolest thing? So you
There
can
is
vote
a
more than once.
Link is in chat on for Zoom.
It's like once per day for the next week. So if you want to participate in this, get on it. You know, we help them, they help us. If you've not been to the Planewave open house events, they're really cool. Not sure if it's happening this year.
Uh-oh.
I was talking with Chris and he said there's kind of scaling it back due to some things. So it might only be a 1-day event. I'll let you know when he tells me what they've kind of settled on. And then astronomy at the beach. I know Bob mentioned it. We've got volunteers. I think I'm gonna let the volunteers figure out stuff for themselves. I've kind of got my table people, I've got my scope people, and hopefully they can just kind of work. Uh-oh, I gotta say it into the microphone. I'm stressed about my own stuff with astronomy at the beach, but I got a tiny little Gemini capsule. 1/120. It's just a little guy. That's it. If you don't help us at Astronomy at the Beach, please still go. It's an awesome event. You certainly don't have to participate on our side to enjoy that event. There's a bunch of stuff there to be enjoyed. We're putting a lot of work into it, so we want you to enjoy it. So come out and everyone like send out the vibes to keep the weather away.
Yeah, one of the things I'm going to be asking the membership to do is we need to start advertising astronomy at the beach. I'm going to be putting together a printable 8.5 by 11 flyer and sending it out. And if you could like take it to your library or to give it to your kid's science teacher, your grandkids' science.
They cause clouds. We know this.
Yeah, tell me about it.
I can't count the number of times I took my telescope to a science fiction convention and everybody said, "Oh, Bob's here. It's going to rain all weekend." So, International Observe the Moon Night is on October 4th. And are we doing anything then?
I don't believe so.
Okay, so
They made me jump through one too many hoops, and I just stopped jumping through.
I have scouts on October 4th at Stargate.
oh, you do? You have scouts there?
Yeah.
So we're doing something on October 4th. All right.
Out there.
So is Vachalia here? Okay, so our newsletter is up. You can see it on our website. That guy won an award for it. So, so if you need to contact the board, you can email the board at warrenastro.org. And now it's time for our special guest, David Levy. Take it away, David.
Well, thank you very, very much. It's really a pleasure to be here. I wish I could be at the Astronomy at the Beach. I was there once and I loved it. And maybe I will be able to come there at some point in the future. Anyway, for my welcoming poetry today, I'm going to quote from Manfred, which is by Lord Byron, and I'm going to, of course, add an extra line to it. When the moon is on the wave, and the glowworm in the grass, and the meteor on the grave, and the wisp on the morass. When the falling stars are shooting, and the answered owls are hooting, and the silent leaves are still in the hollow of the hill, shall my soul be upon thine with a power and a sign, and tonight we go out and observe online. Thank you very much. Back to you.
All right, thank you, David. Right. Lost my place, of course I did. All right, so astronomy in the news. This is on from spaceweather.com. Lunar eclipse reveals the unseen. Last night, would help if I get that. Yeah. Last night, the full moon vanished into Earth's shadow and the stars came out across Asia, Africa, Europe, and Australia. Millions witnessed a sudden transformation. When the lunar eclipse entered the total phase, I was stunned by the sight before me, reports Jeff Dolly of, oh God, I can't even pronounce that, somewhere in China. The Milky Way became extremely bright during totality, and this perfectly outlines the perpetual conflict between dark sky observers, the moon, and planning for astronomy at the beach. Because we're always, the public loves the moon, the observers hate the moon. What day are we going to have it? Interstellar comet 3I Atlas has been imaged by the James Webb Space Telescope. There's an interesting Space Bites news with Fraser Kane saying that it has a very odd ratio of carbon dioxide to water of 8-to-1, the highest ever seen in a comet, and 6 standard deviations above the typical value. So it's a weird one. So, asteroid updates. We still got 1,000,004 total asteroids. Near Earth objects is 39,000. Asteroid 2025 RM1 passed within 0.27 lunar distances on September 3rd. So that was really close. That's within the geosynchronous satellite ring. Exoplanet updates. We are 11 away from 6,000 confirmed exoplanets, and we have 7,600 candidates. The Exoplanet Archive, NASA's Exoplanet Archive, added 6 planets this week. A few of them are gas giants orbiting small red stars, so we're starting to find a lot of those. T. Corona Borealis still has not occurred. Spaceweather.com finally had something additional here. This thing, a new prediction by Gene Schneider of Paris Observatory predicts the nova will occur around November 10th, 2025, or June 25th, 2026, based on periodicities observed in previous eruptions. So, not there yet. Hurry up and wait. Solar, waiting for a CME, a faint CME expected to strike Earth on September 7th. Either missed or its impact was too weak to register. An overdue arrival on the 8th could spark a minor G1 class geomagnetic storm hurled into space by an eruption on September 4th. So that is tonight. Could be an aurora watch. And let's get this up here, see if I can, no, SDO. I'm going to the SDO sites. This is the NASA Solar Dynamics Observatory. This is a observatory orbiting the Earth, watching the sun in multiple frequencies and being very slow. Hello, what are you doing? Excuse me, am I online? Okay, I'm not going to the SDO. The site is down. We have a chain of sunspots across the sun right now. Hey, there we are. Wow, you're taking so long. You're having problems with your data center again? This data center was down due to a flood last year. Oh my goodness. There we go. So there is the chain of. For those online, if you want to see what I'm looking at, I can share this, but just type SDO NASA. So that is the chain of 3 sunspots. See if I can share that picture. Share that guy. That is the photosphere of the sun. Got three big spots. You know, usually they come in pairs of two, so I'd like to see what the magnetic field between those guys is looking at. But so that is the sun today. If you want to see that SDO site, it has 48-hour animations of the sun in multiple frequencies. It's very, very cool. If you're on Facebook, check out CME alerts or solar activity. You could find amateur photos of the sun that would make astronomers from the 18th century cry. Riyadh, you didn't see any double stars last time, did you? No.
Well, actually, we did look low.
Did.
We did see a couple of doubles. Yes, of course. Yeah. Not
Before the raid came in.
Yeah, just nowhere near as good with the 8-inch refractor. Looking at, using the 10-inch Dob. As good as the 10-inch Dob is, it's nowhere near the sharpness of the 8-inch refractor.
Really?
Yeah.
So if you want to start a special interest group, if you're interested in doing radio astronomy or computers, technology, education, light pollution, which I'm probably doing, podcasting, let us know. Do it and let us know about it. Observing reports. Did anybody see the eclipse? Don't think so. Yeah. Yeah. Anyone else? Any observing reports? Anybody see anything in the sky other than the moon?
Got some photo from last May and June.
What do you got? Oh, Doug.
Show it?
Are you sharing something?
Would you like me to?
Please.
Okay.
Absolutely.
I don't know if I've shown this before, but I haven't been on in a while. So let's see. There we go. There. And there. And share. Okay. So I bought a C-Star S50 back in May 4th, and in May and June I went up to my Boone property and used it a couple times, and these are the things I got. This is the Crescent Nebula. This is the Eastern Veil. This is the Iris Nebula. A lot of dark nebula in that object. Of course, the Dumbbell Nebula, everybody's easy one to photograph. This is the Trifid. A lot of background nebula as well. And M51, 81 and 2.
Wow, you can actually see some of the active core on that one too. That's amazing.
Yeah, this
Wow.
is just a little that 50 millimeter lens. And then this is the elephant trunk. And that's all I got, unless you have questions.
Oh, thank you. That's awesome. I was actually I was talking with somebody at that Vatican Observatory Full Moon Zoom about the C star, and I searched on it. It's a type C star, and what came up was C star S70 coming soon.
Yeah.
So
I'm waiting for that.
yeah.
If that comes, I'm gonna pick that up too. But this is my mobile rig now. It's only this big.
No idea what the specs on that are.
On the 70? No, it's probably an F5 though. Okay. Stop sharing.
All right. Anybody else have any astrophotos? No? All right. Well, then we can get into our short talk. Dale. Let's get your presentation up and shared here. Let's see, which one is it? There. View slideshow, first one. And how do I share that with these guys? Should yes, share the screen, I guess. Good with that on the side there like that? You want me to get down to one? I was gonna leave it like that. Pardon me?
Down to one.
All right, let's see. Pin. There we go. Walk away. It's working.
Well, it's my pleasure to introduce Dale Teamy. He joined the Warren Astronomical Society in 2007. He's got the beard to show it. Starting in 2012, he joined the board of this organization, served on it for 8 years as secretary, then treasurer, then publications director. And when he was doing publications, he fell in love with doing the WASP newsletter. So he's been doing that for years now, sort of as an editor. He even earned an award for the WASP a few years back. He's into being an armchair astronomer. And tonight, he's sort of our resident historian. He went back through all the issues of the WASP back to the beginning of this, back in the early 60s, right?
69 when they started doing the WASP.
69. And they're all online, so you can see what the club was doing way back. Therefore, he's a historian of the Stargate Observatory, and he's here tonight to share a short history of Stargate. Dale?
Thank you, Dale. Well, I'm not seeing my notes. Oh, you need notes? Yeah. Didn't know that. All right, Bill Street. Tech support.
All right. I gotta do the dual screen. Put it over there. Let's see. Keep presentation. I see the notes. Show speaker notes.
Start the slideshow.
Well, the thing is, I can do it on here, but gosh, can you do it like they can't do it like that, can you? Well, what can you do about this? Can you do it like that? I can't.
I'll show them my notes up there now.
Yeah, I know. I can't do the dual screen thing though.
Well, just
They got
let's see.
the view in that.
This isn't PowerPoint, is it?
No. It's. All right, so
That's
yeah, we'll move this over here.
slide it.
Yeah, slide this over here.
You do need the two screens that are not.
Yeah. Yep. So there's the two screens. Keep that. So now. So that's the presenter view. That goes away. Now zoom. Share. Yeah, I know, sorry. Share screen 2. That should do it. Okay.
Okay,
Here. There you go. How's that?
yeah, we're on slide 3 already.
Go full screen with your slides.
Where's the,
Click it, hit up a line.
I think it's screen for size. Oh, there we go. Okay.
Back to the beginning.
There we go. Okay, a full length treatment of the history of Stargate was given by Jonathan Cade. You cover up my notes. Jonathan Cade on October 17th, 2019. This will hopefully be a much shorter version, although I have my doubts now. I put a link to Jonathan's talk in my History SIG column in the September WASP for anyone wanting to see Jonathan's presentation. Now, from the outset, the Warren Astronomical Society met in several school locations, finally settling in at Lincoln High, which had a dome, but no telescope. Soon, whoa, soon the club built an F4 Newtonian telescope for the dome as a group project. Its debut was in 1966. No.
Dude, businesses in Chicago have to tell us.
You gotta mute somebody there. So the club built an F4 Newtonian telescope for the dome as a group project. Its debut was in 1966. I suspect Warren light pollution may have had some influence on the location to move on. Then okay, quoting from the April 1969 edition of the WASP, the club's excursion to Camp Rotary to time the occultations of the Pleiades was interesting to say the least. If the evening skies that night were typical of the area, it should prove a superb sight for our 12-inch. Then from the May 1969 issue, the grounds committee looked over designs for the building submitted by Mr. Leah and Mr. Paulus and seemed very much in favor of the project. It is possible that they will contribute money and materials to the cause, and they seem to desire a cement block domed structure. Construction commenced in 1969. Hoffley Manufacturing provided material for the dome framework and shaped the pieces. Club members cut and finished the dome framework, then welded it together. Sheet aluminum was cut and riveted to the frame, then placed the dome on the roof. Stargate Observatory went to operation in the spring of 1970. Construction commenced in 1969. Hoffley Manufacturing provided material for the dome framework and shaped the pieces. Club members cut and finished the dome framework and then welded it together. Sheet aluminum was cut and riveted to the frame, then placed the dome on the roof. Stargate Observatory went into operation in the spring of 1970. The telescope was refigured by founding member and former president Jerry Leah as a classical Cassegrain and was moved to Stargate Observatory during the spring of 1970. In the 70s, we held lectures for the Scouts every weekend with a rotating list of volunteers. Shown here is a list taken from the October 1977 WASP. I reached out to Ray Bullock about his experiences lecturing at Stargate, and he says, "Oh yes, I remember those days well. WASP members who had been trained on the operation of the telescope took turns opening the observatory on either Friday night or Saturday night. As you know, there was a list of who was given or assigned on a given date, but sometimes the notifications didn't get out on time and nobody showed up. The schedule was flexible, so if someone had a conflict, another person could cover. Showing up was dependent on two things. First, as you said, there needed to be scouts at Stargate. Second, what was the weather like? We committed to Friday and Saturday, hoping that one of the days would have good weather. If we opened on Friday, we didn't have to open on Saturday as well. If both days were inclement, we didn't need to show up. Occasionally, some members would present a program in one of the cabins, but observatory volunteers were not expected to do so. The late Frank McCullough was exceptionally talented with his presentations. Signed, Ray. Fast forward to 1996. Since the Stargate telescope was permanently stuck in the observatory, the club decided they wanted to construct a telescope of large aperture that would be portable. John Hergott, who was the club president in 1996, proposed building a 22-inch truss reflector telescope on a Dobsonian mount. Even in 1996, the cost was going to exceed $5,000, and that was with club labor to construct the telescope. The Big Dob was semi-portable at this point. It could roll around on its own wheels, but could not stray far from the observatory. The club sought out a trailer to transport the Big Dob. Now it could travel far and wide. Here we see at the Astronomy at the Beach event, miles from Stargate. In 2002, the club built the Dob shed to house the 22-inch telescope assembled. The building has concrete floor, lights, and electrical outlets. Now the members could roll the Dob in and out of the shed without having to break it down. Meanwhile, we have pictures of Stargate on a more or less annual basis. Here we see the initial announcement of any kind for the first annual picnic. Now, this picnic might have been among the last at the observatory location. Actually, I found out we moved to the pavilion in 2012. So after enduring blistering heat and monumental downpours at recent picnics, 2012, we moved operations to the Rotary Pavilion, a short hike away. The two pictures above are interesting in that they feature four members who sadly are no longer with us. Bob, what you see at the left of his back to us, Dick Galla in the yellow raincoat, Marty Coons, and Brian Klaus at the far right. After 40 years service, the accumulated stress of Michigan winters and a number of leaks took a toll on the roof of the building. In 2009, WASP members tore off the roof and built a new roof redesigned to eliminate the flat spots at the corners of the building. The sheet metal on the dome was refinished. A couple years later, we fixed some last nagging leak issues, then put in a platform floor and repainted the interior. Bob Berta made a commemorative plaque, the Bent Hammer Award, honoring those who helped with the reconstruction project. Here's Brian Teamy holding the plaque at the awards banquet. Bob, that hammer was actually one that was damaged at the construction.
Cheap hammer.
Yeah, yeah.
No, it was steel, but it's
Yep.
probably Chinese steel.
Yeah. Special open houses at Stargate were held for such occasions as the International Astronomy Day and actual astronomical events like the 2012 transit of Venus. Yeah. Regularly scheduled open houses on the fourth Saturday of the month would often feature lectures, a tour of the observatory and weather permitting, a star party with members bringing their telescopes to share a view of the sky and beginners bringing their new scopes to get training. After Larry Kalinowski, a true pillar of the club, passed away, his son, Mark, made a substantial donation to the club in his father's memory. The board decided a new scope in the observatory would be just the ticket. They purchased an 8-inch f12 refractor with an astrophysics focuser from D&G Optics. This was the biggest refractor we could comfortably squeeze in the dome. Joe Tocco constructed a temporary cradle so we could mount the scope on our existing drive until a proper replacement of the drive could be obtained. Here we see Joe and Riyadh making sure the scope clears the dome motor. It just fit. And now we're cooking. As a finishing touch, we hung Larry's picture in the observatory. The old mount with the adapter cradle was to be a temporary fix. While the board sought a suitable mount for the new telescope, WAS member Andy Kula offered his Astrophysics 1200 GTO mount. We installed it and added a finder scope, an Explorer Scientific apochromatic refractor donated by Ken Burton. And the Kalinowski Kula telescope was in business. And here is a picture of Andy hanging a Stargate. And this is Mark Kalinowski during a visit to our observatory a few years back to check out his dad's legacy. And that brings us up to date. Thank you.
Righty. All right, so now as we take our snack break, so take a 20-minute break, take a bio, get a munchie, get a drink, and meet back here in 20 minutes, which is going to be at what, about 10 after ish. So be back in 20.
Well, I took mine off.
All right, so now I've got great presentation.
Gotta go back to the PowerPoint.
Get to go away. You get to go away.
Right, Joe? From current slide.
Okay, there's that. Now we got to zoom.
How are you doing? I'm very hard of hearing.
Same here.
This microphone spears right to my hearing aids. If you would, you can either wear or
Can I just leave it up here?
this flips. Whichever way you prefer.
It won't work if it's just sitting up here. Right up here. Would it work that way?
How's everybody doing?
Trying to get the presentation up here.
Oh, no.
Would it work up here?
I don't think that'll work good enough.
Okay.
Excuse me.
I'm not very stable there.
Hey, Bob, before I leave, I just want to talking to Jeff. He said to talk to you about streaming from a sea star, maybe astronomy on the lake.
Really?
Yes, well, I've been doing it from home.
You have.
I have,
Okay,
so,
thank you.
Okay.
but I could talk to you after.
Yeah, I'm trying to get this up and running here.
Take.
I gotta get this up and running. I'm sorry. I can't do this right now. All right, so this is our sharing that. Now I want continue. There's Jim. So they see your beautiful face. And now your presentation is right there. So now
Slideshow from current slide.
there it is. And now not doing it, but I'm doing it.
Remember having this problem before.
Yeah, right.
Oh, that's all right.
Thank you, sir.
And now, there we go.
Okay.
That big enough? You want that bigger?
Well, no, that's fine.
Okay.
That's good.
Okay, so you just
That's all right.
scroll
Now,
down.
are we broadcasting like you want?
Yes. You should. Hey, Dale, do you see your presentation? Yeah, you see, there it is right there. Oh, wait, that's
Wow.
yes.
Don't forget to demo.
Okay.
He's got the main slide on.
All right, so we're broadcasting.
Okay, okay, but we're not looking at me at all. Is that correct? That's
We
fine.
got no, we gotta look at you. Where's your Zoom? Video. All right, so now they're seeing your face.
Okay.
All right, so now I gotta
That's
get,
not very important, but we do still need a chair.
yeah, I'll be right now.
Thanks, Dale.
Hey, Dale, I'm just gonna stand up here because it'll be more efficient, so I don't stumble up the stairs.
Yeah, he's getting a chair up here. Yeah, there we go. Good enough. Yeah, I still got it. I was okay up for it. My son, when I was up there last week, what you been up to? I told you, I got a pistol. The bourbon. And I got a place with my fire that up to 100 yards. And then we talked about doing this for 5 or 6 years. One of my neighbors. Monitor. And if that's, I was up there like a week. Cool.
Where's my phone?
I had one of those. I have heard, but when I had my dad did. American Legion went out of business.
Right in front of my face. All right, 3 minutes.
But I haven't gotten it. I carry it.
Yeah.
Actually, I was there. Very often, a couple of years when they got rid of them.
Okay, 2 minute warning. Finish up your bios, get your munchie, grab your seat, and let's get the show back on the road in a minute. Okay, take your seats. We're gonna have our feature presentation now. Where's the light switch? Oh, that would be right here. Will I turn down or is that okay?
This is okay. Okay, anyone who's been around this organization for a while knows Jim Shedlowsky. But for those who are newer here, Jim graduated from the University of Michigan back in 1960 with a degree in engineering physics. He then spent 2 years as an artillery officer in the U.S. Army in Germany. He worked for 36 years at General Motors as a vehicle development engineer or manager, specializing in acoustics, noise, and vibration, retiring in 1999. In his spare time, he wrote and recorded music for Epic and Roulette Records as one of the Skee Brothers. I assume that was the plastic records we used to play.
Yeah, that's plastic records, 45s.
Yeah, really goes back ways. And he's been a member of this organization since 2002. His topic tonight is the way we found the universe. Sounds kind of interesting. Let's hear about it, Jim.
Thanks, Dale. All that stuff he just told you will reinforce your idea that I'm an old timer. I just turned 88 last February, so I'm getting up there. In any event, again, my name is Jim, and I hope you'll save your questions till the end because this presentation is almost exactly an hour long. So, 1925, just 100 years ago, was an interesting year for many reasons. Adolf Hitler published Mein Kampf in 1925. Calvin Coolidge was president. Scotch tape was invented in 1925. The Grand Ole Opry started in Nashville, Tennessee, and Tennessee outlawed the teaching of evolution, leading to the famous Scopes monkey trial in 1925. And the Chrysler Corporation was founded by Walter O. Chrysler in 1925. But on New Year's Day in 1925 in Washington, D.C., at a joint meeting of the American Association for the Advancement of Science and the American Astronomical Society, a modest but earth-shaking paper entitled Cepheids in a Spiral Nebula was presented, which announced to the astronomers assembled, there were some 80 of them, that the universe was vastly larger and quite different in nature than previously known. The paper was presented by noted astronomer Henry Norris Russell from Princeton, who stood in for its author, Edwin Hubble, who astonishingly was not present, but back home at the Mount Wilson Observatory in California, intentionally hiding out. This paper and Hubble's 1929 paper revealing the expansion of the universe marked the culmination of one of the most exciting periods in the history of astronomy, a period filled with major advances in technology. Whoops, I gotta get, there's, gotta find my cursor here. Just scroll down. Yeah, but my cursor wasn't on the screen, so. That paper and Hubble's 1929 paper revealing the expansion of the universe marked the culmination of one of the most exciting periods in the history of astronomy, a period filled with major advances in technology like large reflecting telescopes, spectroscopy, astrophotography, brilliant and inspired individuals like Hubble, Einstein, Henrietta Leavitt, and others, and a series of wonderful events which led to Hubble's profound redefinition of our universe. This period also marked America's ascension to the top in the world of astronomy. Okay. And we got to make the buttons work here. Let's see. My presentation will attempt to review that exciting period of some 30-odd years from the turn of the 20th century until about 1930. What do I mean by we found the universe? Webster says to find means to come upon by searching or effort. Number 2, to discovered by study or experiment. Or 3, to obtain by effort or management. My phrasing of the finding of the universe meets all of these definitions. At the turn of the 20th century, only 125 years ago, our concept and knowledge of the universe was much different than it is today. Our grasp on the age, the size, the composition, and the very nature of the cosmos was rudimentary and mostly in error. Take, for example, the age of the universe. Since ancient times, how old is the universe has been asked. For about 2,000 years, the accepted answer came from the philosopher Aristotle's declaration in about 350 BC that there is only one heaven and it is ungenerated and eternal. Then came the Copernican revolution of the 16th century, which challenged Aristotle's Earth-centered universe and prompted suggestions that a finite age was possible. But how old was it? The best thinkers of that time, the 16th and 17th century, agreed that the age of the universe should coincide with the age of the Earth. And that could be determined by a careful interpretation of the biblical creation account, supported by the astronomy of the day. They converged on an age for the Earth and the rest of creation of somewhat less than 6,000 years. This slide shows the creation dates calculated by various notables of that time using these methodologies. Note that Kepler, Longomontanus, and Isaac Newton, noted scientists at that time, were among the chronologers. This approximately 6,000-year-old age of everything seemed adequate until the 1800s, when other scientific fields, such as paleontology, the study of fossils, and geology, suggested the need for a much older Earth to accommodate their observations. An interesting related sideline to this quest for an older universe involves several noted scientists of the 19th century. Hermann von Helmholtz from 1821 to 1894 and Lord Kelvin from 1824 to 1907. They separately calculated in the mid-1800s that if the sun were generating heat energy by burning fossil fuels such as natural gas or coal, it could only last for 1,000 to 10,000 years, much too short for the geologists and paleontologists, or even those upstarts, the Darwin evolutionists. So with creative thinking, they proposed the Kelvin-Helmholtz mechanism, which would, by using energy from the sun's gravitational collapse, extend the sun's age by 1,000-fold to some 20 to 40 million years. This is per Lord Kelvin in 1897. This was older, but still much too young for the other science disciplines. Thus, by the close of the 19th century, the age of the universe, as judged by the scientific community, based on the estimated age of the sun, was 20 to 40 million years, still many times younger than the age of the Earth, as judged by geologists and paleontologists of that time. Similar naivety existed at that time in our knowledge of the size of the universe and its nature. Copernicus had moved the Earth from the center of the universe in the 16th century, along with support from Galileo, Kepler, Newton, and others. But in 1900, the sun was still considered to be at the center of the Milky Way galaxy, which was still considered to be the extent of our universe. This universe was thought to be about 30,000 light years in diameter. At this time, the only reliable measure of cosmological distances was by parallax or triangulation, which had been accomplished only on 25 of the nearest stars, out to a distance of about 163 light years. So at the turn of the 20th century, only 125 years ago, the nature of the universe generally accepted by the astronomical community may be summarized as follows. The solar system was at the center of the Milky Way universe. The Milky Way was the entire universe. The Milky Way universe was about 30,000 light years in diameter, and the age of the sun and the universe was about 20 to 40 million years old. And spiral nebula, we'll talk a little bit more about them in a moment. Spiral nebula were emerging planetary systems within the Milky Way. All of these assumptions were wrong. Thus begins our story. In 1898, James Keeler returned to the Lick Observatory on Mount Hamilton in California as its director. Keeler had spent several years at Lick from 1886, when it began operations, until 1891, honing his skills in spectroscopy in the fledgling field of that time of astrophotography. The Lick Observatory was the world's first modern observatory built on a remote mountaintop, and James Keeler was directly involved with getting it up and running. When he returned in 1898, after a notable tenure as the director of the Allegheny Observatory, he promptly adopted the recently acquired, but not yet operational, 36-inch Crossley reflector telescope as his own, and embarked on a program of examining the mysterious Spiral Nebula. This unprecedented pioneering program, using a large reflecting telescope at a high altitude with, at the time, modern photographic technologies, yielded such breathtaking results that the astronomy community took note. The day of the refractor was over, and spiral nebula were a seemingly different entity and were much more numerous than previously thought. Keeler estimated there to be 120,000 of them versus the 79 previously identified. Based on finding numerous ancillary spirals in each of his photographs, this shows a photograph of NGC 891, an edge-on spiral in the center, and then in the upper right boxed area, showing in detail many other faintly likely spirals. Keeler had, in a year and a half, single-handedly turned large reflecting telescopes with astrophotography and spectroscopy into astronomy's instrument of choice, and he had made spiral nebula a matter of prime concern for professional astronomers. Keeler had reached the top of the astronomy world and was destined to restructure its view of our universe when he died unexpectedly on August 12, 1900. It would be almost another decade before his reigns would be picked up and pursued by another Lick astronomer, Heber Curtis. Now I'd like to digress here for a moment and talk a little bit about spiral nebula as they were known in the 19th century. In a few words here about the perception of the spiral nebula in the 19th century, observation of these faint deep sky objects for much of that era was limited to visual observations. This is before astrophotography. With drawings from the eyepiece of telescopes, considered modestly primitive by today's standards. The most influential astronomer in that era was William Herschel, who by 1800 had concluded that any nebula unresolved by his telescopes must be, quote, collections of new luminous matter or clouds of gas, and not of a starry nature. Herschel's telescopes and techniques were so much better than any other astronomer of that time that his colleagues trusted his judgment, and it became the wisdom of the day. An example of his observations is shown on this drawing from 1811, showing various forms of nebula as seen and sketched by Herschel. Then in 1845, an Englishman, Lord Rosse, made his famous drawing of M51, a spiral nebula, as seen through his monster Leviathan 72-inch reflector telescope, clearly showing a spiraling structure, but failing by orders of magnitude to resolve the nebulosity as stars. Then, in 1887, using very early photographic techniques, Englishman Isaac Roberts captured a full photo of M31, the Andromeda Nebula, an incredible photographic feat at that time, which again confirmed its nebulosity. In 1885, a nova, that's an exploding star, was observed in Andromeda and was so bright that the astronomers of the day reasoned it had to be relatively close by, that is, inside of the Milky Way. Because in this pre-nuclear era, no physics then existed to explain its energy production and brightness otherwise. In 1895, another nova event in NGC 25 or 5253, another spiral, evoked similar conclusions. And so, by the end of the 19th century, despite some indications to the contrary, most astronomers had settled on a common explanation for the spiral nebula, that they were new stars within the Milky Way, with new planetary systems forming just as our solar system had formed. Keeler's amazing photographs suggested other possibilities, but he was dead. His successor, Heber Doust Curtis, was an improbable person to play a key role in the discovery of the universe. Curtis was a dedicated student of ancient languages, Latin, Greek, Hebrew, Sanskrit, Assyrian, at the University of Michigan, and went on in 1894 to become a professor of Latin and Greek at a small college in California. That's the Napa College at the University of the Pacific. But it was fortuitously near the new Lick Observatory. He found a small telescope at the college and began to tinker with it. And he became obsessed with his new hobby and spent the summers of 1897, 1898 at Lick on Mount Hamilton as a special student assistant. This experience led him to abandon his professorship and obtain a PhD in astronomy from the University of Virginia in 1902 and joined the staff at Lick Observatory. His initial work at Lick involved routine observations and learning the techniques involved with large telescopes, astrophotography, photometry, and spectroscopy. He was then assigned to head up Lick's southern station in Chile. It wasn't until 1909 that he was recalled to Lick as a senior astronomer to work with the 36-inch Crossley reflector, just as Keeler had. And to carry on the work began 10 years earlier by Keeler, that is, to tackle the mystery of the spiral nebula. Over the next 11 years, from 1909 to 1921, with a short hiatus during World War I, Curtis photographed more than 500 spiral nebula and studied their patterns and characteristics closely. He noted that each of his photographs revealed more faint nebula surrounding the more prominent spirals that he officially cataloged, just as Keeler had. Curtis estimated at that time that there were more than 1 million spirals within the reach of the Crossley. He also noted the dark lanes that were prominent in many of his spirals, which he surmised were related to the dark regions of the Milky Way. Curtis had come to the conclusion that the spirals must be external island universes, and by 1919, he was a champion of that school of thought, while continuously searching for further confirmation. In 1917, both he and George Ritchie at Mount Wilson had detected faint nova in several of the spirals, further strengthening his hypothesis. The mainstream astronomy community, however, required more convincing evidence. It was to come from another astronomer at another observatory. As a sidebar, for those you Michiganders, Curtis went back to Ann Arbor, where in 1930 he became the head of the astronomy department at the University of Michigan, my alma mater, playing a key role in the development of the McMath-Hobart Observatory in Lake Angeles, Michigan, into a world-class solar research facility. Also, as we shall see, Curtis represented his view of the universe and the spirals in, quote, the Great Debate of 1920. More about that later. But for now, let's go back to our story, this time in Flagstaff, Arizona. Vestal Melvin Slifer may lay claim to the longest tenure at a single observatory of any notable modern astronomer. He spent 53 years between 1901 and 1954 at the Lowell Observatory in Flagstaff, Arizona, 38 years as its director. Lowell was the private observatory of Percival Lowell, the wealthy eccentric who was so obsessed with the possibility and probability of life on Mars that he built a major observatory to study it in 1894. At the turn of the century, the Lowell Observatory and the Lick Observatory we've been talking about were major competitive institutions in the world of astronomy, each seeking to outdo the other. It was a personal directive in this regard from Lowell to Slifer in 1909 that led to his greatest discovery, a discovery which rocked the astronomical world, that spiral nebula were moving very fast, at speeds many times faster than stellar velocity or than star velocities. Slifer had become a master of the spectrograph, but the challenge of obtaining a spectrum of these faint fuzzies out there with the then existing equipment was daunting and had never been done before effectively. These spectral images enabled a measurement of the velocity of cosmic objects using the Doppler effect. His early results in 1911 indicated peculiarities in the spectra of Andromeda Nebula, which were confirmed in 1912, when an exposure which took over 3 nights of manually guiding the 24-inch refractor at Lowell, which revealed that it was rushing toward the Earth at the ridiculous speed of 300 kilometers per second, incredibly close to the modern figure of 301 kilometers per second. This amazing result encouraged Slifer to greater efforts to record the spectra of even fainter spiral nebula with exposure times of from 20 to 40 hours. His third target was NGC 4594, the Sombrero Nebula, which was found to be moving at more than 3 times that of Andromeda, or 1,000 kilometers per second, this time moving farther from the Earth. His determined efforts had, by mid-1914, secured the velocities of 15 spiral nebula, most of which were receding from Earth. He presented these results in August of 1914 to the annual meeting of the American Astronomical Society at Northwestern University in Evanston, Illinois. A meeting interestingly attended by a young graduate student from the nearby Yerkes Observatory in Wisconsin named Edwin Hubble. Schleifer's paper entitled Spectrographic Observation of Nebula reported that the average speed of the 15 spirals measured was 25 times the average velocity of stars in the Milky Way, and that 12 of the 15 nebula were moving away from Earth. Schleifer's remarkable results were received by the assembled astronomers with awe as, quote, one of the greatest surprises encountered in recent times, end of quote. Schleifer continued his measurement program and by 1917 had presented results on 25 spirals with 21 of them receding. And by this time, he suggested that his data tended to support Heber Curtis's, quote, island universe theory. But the success of that theory required one more key piece of information. How far away were these spiral nebula? And so now our story turns to an inspired young woman in Cambridge, Massachusetts. You may recall that in my introduction, I mentioned that at the turn of the centuries, astronomers had measured the distances to only some 25 of the nearest stars, out to a distance of about 163 light years, using parallax and triangulation, or geometry, if you will, with the diameter of the Earth's orbit as a baseline. The next step in determining the nature of the universe required a new insight or breakthrough in the ability to measure much greater cosmological distances. This breakthrough came about from the inspiration and dedicated mind of a young woman and the chauvinistic attitudes present at the turn of the 20th century American society. The woman was Henrietta Leavitt, who, having been inspired by an astronomy course during her last year at Radcliffe, stayed on in Cambridge, Massachusetts to work as an unpaid helper at the Harvard Observatory. As a volunteer in 1892, she became an expert in stellar photometry, that is, assessing the magnitude or brightness of a star by examining its size of its image on a photographic plate. Harvard, under its director, Edward Pickering, had embarked on a formidable task to photograph and classify every star in the sky as seen from both the northern and southern hemispheres. They had amassed a huge number of photographic plates which required analysis. Pickering had shrewdly recognized the value of smart young women who were capable of doing as much and as good routine work as his male astronomers, who would receive a much higher salary. So he could hire 3 to 4 times as many assistants and employ them for the same expenditure. These women, some 40 of them, were called computers, or Pickering's harem by some. Henrietta, who had left Harvard in 1896, returned in 1902 when she was hired for full-time employment at a premium wage of 30 cents an hour in view of her previous experience. This is a little over today's minimum wage considering inflation. Henrietta resumed her study of and fascination with variable stars. In 1904, while examining photographic plates of the small Magellanic Clouds, that's in the southern hemisphere, from the Harvard station in Peru, she noted with interest several variable stars. Over the following years, she found dozens more, and by 1907, she had tallied 1,777 new variables in the small and large Magellanic Clouds, where previously only a couple of dozens had been detected. A Princeton astronomer called her a variable star fiend. Of particular interest to her was a small subset of these variables from the small Magellanic Clouds, some 16, that shared similar characteristics of regularity and brightening. Their periodicity ranged from 1.2 days to 127 days, and she noted in her report that, quote, "It is worthy of notice that the brighter variables have the longer periods. By 1912, she was able to add 9 more of these Cepheid variables and publish her findings in a 3-page paper at the Harvard College Observatory Circular, the Harvard College Observatory Circular, along with a chart, clearly showing the relationships between periodicity and luminosity of the Cepheids, all of which were in the small Magellanic Cloud, or at roughly the same distance from Earth. This amazing marriage of observation and deduction by a mostly self-taught astronomer was one of profound importance to the astronomy community. Cepheids now stood to be the perfect standard candle if true luminosity or brightness of at least one of them could be found. Once her graph was thus calibrated, astronomers could gauge the distance to celestial objects much more distance than ever before. Although Henrietta was not given the opportunity to take this final step, after all, Pickering shows his women computers to work, not to think. Her work belatedly received wide acclaim. In 1925, a member of the Royal Swedish Academy of Sciences contacted Harvard for information to nominate her for the Nobel Prize in Physics. Unfortunately, she had died 4 years prior to the inquiry, but her accomplishment will echo through the rest of my presentation. But now the drama continues with the introduction of the director, George Ellery Hale, who should be known as astronomy's greatest enabler. Without Hale, there would be no Howard Shapley or Edwin Hubble. More about them later. He nearly single-handedly orchestrated the construction of 4 great telescopes, each one the largest in the world, and each one larger than previous. He personally selected the location and founded Mount Wilson Observatory, the site of 2 of these telescopes, and then hired both Shapley and Hubble to use them in the final chapter of The Way We Found the Universe. A noted astronomer in his own right, Hale invented the spectroheliograph while still in college and discovered the magnetic structure of sunspots. Hale was a close personal and professional friend of James Keeler, who we mentioned earlier, before Keeler's death in 1900, and who had piqued his interest in cosmology and astrophysics and large reflecting telescopes. In 1895, he and Keeler co-founded the Astronomical Journal, still the world's authoritative reference in this field. He was instrumental in the founding of the California Institute of Technology, Caltech. It was Hale who took George Ritchie from teaching in a high school woodshop and facilitated his transformation into the premier telescope designer and builder that he became. Hale was indeed bigger than life, a mover and shaker who, through his focused effort over several decades, caused America to seize the baton from Europe in astronomical leadership. Noted astronomer Alan Sandage in 1980 summed up Hale's career and contributions as follows. Astronomers owe all to Hale and his dreams and positive actions to put those dreams into glass and steel. Where would the world of astronomy be today if Hale had not been an empire builder? End of quote. And so, if in the discovery of the universe we have many actors such as Keeler, Curtis, Slipher, Leavitt, Shapley, and Hubble, then surely the director of this drama must be George Ellery Hale. And now, on with our story. In 1908, through the initiatives of Hale, a new modern observatory at Mount Wilson with its new 60-inch reflector began operations to rival the Lick and Lowell facilities. Hale's vision for this new venture was to promote and produce new fundamental discoveries in the emerging fields of cosmology and astrophysics. He preferred his astronomers to take chances, and in 1914, he hired a recent Princeton PhD who would fit this category. Harlow Shapley. As Hale noted later, quote, Shapley is more venturesome than other members of the staff and more willing to base far-reaching conclusions on rather slender data, end of quote. Shapley came to Mount Wilson with an interest in globular clusters that became his passion. Using the 60-inch telescope, Shapley surveyed the colors and magnitudes of the stars in the most prominent clusters. And his collection of photographs grew. As his collection of photographs grew, he began to identify Henrietta Leavitt's Cepheids, which he knew would serve as distant markers to his globulars. If only Miss Leavitt's chart could be calibrated. Since no Cepheids were within the range of parallax measurements, the closest Cepheid is Polaris, and that's 430 light years away. Other tenuous methods were employed, such as using very limited data regarding the proper motion of some 13 Cepheids within the Milky Way. This method, employed earlier by N.J.R. Hertzsprung and then by Henry Norris Russell, gave crude distance calculations to the small Magellanic Cloud of about 30,000 light years to 80,000 light years, versus what we know today as 210,000 light years. Shapley adopted Russell's approach and then changed it with several controversial modifications and assumptions. Using this ballpark calibration, he was able to estimate the distance to the nearest globular clusters. For clusters farther out, he resorted to using the brightest stars as distances, as distance markers, with the assumption that the brightest stars in all globulars had the same magnitude. Then, when the stars themselves could not be resolved, he judged distances by the apparent size of the cluster, another assumption. When he was finished, he had secured the Shapley distance to every known globular cluster in the Milky Way, some 69 in all, noting that their distances were anywhere from 20,000 light years to 100,000 light years, much too far to fit within the classically sized Milky Way, which was known as 30,000 light years. After plotting the location of these 69 globulars, he also noted that most of them resided in one particular direction, toward the constellation Sagittarius. Not evenly distributed as they should be if the Earth and Sun were in the center of the Milky Way. Shapley's findings, assumptions, and to a certain extent his speculative nature eventually led to his reassessment of the Milky Way and the universe as a whole. In a series of papers published in 1917 through 1919, Shapley shook up the worldwide astronomy community with his definition of the Milky Way and its implications. His definitions were, number one, the Milky Way is 30,000 light years in width, not 30,000, 10 times its classic size. Number two, the solar system is not at the center of the Milky Way, but some 65,000 light years from the hub. Number three, globular clusters are uniformly scattered around the galactic center in the direction of Sagittarius. Shapley's revelations met with praise for its incorporation of new data from the large Mount Wilson telescopes. The 100-inch hooker was now online. And the novel deductions reached. His findings also met wide skepticism by those not convinced of this new cosmic scheme. Conservative astronomers were most concerned about the many assumptions and analytical leaps of faith made by Shapley in reaching his conclusions. His biggest accomplishment, though, was that by 1920, there were at least two major schools of thought regarding the nature of the universe, the nature of the universe. As almost an afterthought, Shapley dismissed the Keeler-Curtis external island universe theory of the spiral nebula as highly improbable. The Shapley universe was now the much expanded Milky Way, which was now all-encompassing. Additionally, he now subscribed to his friend and and fellow Mountain Wilson astronomers Adrian van Manen's recent findings of detectable rotations in the spirals, implying that whatever the spirals were, they were relatively close and within the expanded Milky Way. But who was Adrian van Manen? The villain in our drama. Van Manen was a respected astronomer hired by Hale at Mount Wilson in 1912 because of his reputation as a careful observer with meticulous integrity in his techniques. He began working with the Spiral Nebula in 1915 when George Ritchie asked him to compare photos of M101, the Pinwheel Nebula, taken 5 years apart, to look for changes. After an extended study involving new techniques and additional photographs from 1899, 1908, 1914, van Manen deduced that M101 was rotating with a full rotation of every 85,000 years. A rotation rate this rapid meant that if the pinwheel were truly the size of the Milky Way and located off in distant space, then its outer edge must be traveling faster than the speed of light, an impossibility. Van Manen expanded his study to include other spirals and measured rotational periods of 160,000 years for M33, 45,000 years for M51, the Whirlpool Galaxy, and 58,000 years for M81. The current value for the Milky Way is 250 million years. So you can see there's an order of magnitude difference between Van Manen's inspiration and what reality was. The implication was clear that if Van Manen's findings were correct, then the spirals must be much closer and smaller. The astronomical community took note because of the nature and the source of a respected astronomer from the world's foremost observatory. But there were both supporters like Shapley and skeptics like Curtis, and the controversy continued. The stage was now set for a showdown. In April of 1920, at a meeting of the National Academy of Sciences in Washington, D.C., an event took place in the Baird Auditorium of the Smithsonian Museum of Natural History, an event forever known in the world of science as the Great Debate. This event was arranged by Hale to honor his late father. Hale's first choice of a topic was a discussion of Einstein's recent revolutionary general theory of relativity, which had just been confirmed the year before by the measurement of starlight deflection during a solar eclipse. When relativity was deemed too incomprehensible for the ascended scientists, Hale's second choice became the chosen topic, that is, the unresolved issue of the island universe theory. The opposing speakers, also selected by Hale, were Howard Shapley and Heber Curtis. After some negotiations, the title for this event became, quote, The Scale of the Universe, and the so-called debate would become more of a discussion, two talks on the same subject. On the evening of the Great Debate, April 26, 1920, Shapley went first. He gave a general talk on basic astronomy with descriptions of the Milky Way, its structure and its constituent parts, the stars, nebula, and the clusters. He accompanied his speech with slides of the new 100-inch Hooker telescope, the moon, the sun, the Pleiades, and its favorites, globular clusters, but notably not of spiral nebula. Shapley focused on his big galaxy model without delving into the technical details for his distant measurements. He stressed that the Milky Way was immense at 300,000 light years in diameter, 10 times the previously accepted value, and that the sun is not at its center. He only briefly mentioned the spirals, stating, quote, I shall leave that description and discussion of this debatable question, the spirals, to Professor Curtis. Curtis's talk was more technical, detailing why he disagreed with the big galaxy model, mainly because of Shapley's casual use of the Cepheid yardstick, along with what he explained were numerous tenuous assumptions. He placed the size of the Milky Way at 30,000 light years in diameter. He then focused on the spiral nebula, noting, one, that the spectral signatures indicated them to be a collection of stars and not gaseous in nature. Number two, their distribution was primarily away from the Milky Way. And number three, the novae being sighted in some spirals were too dim to be within the Milky Way. And finally, their high velocities as measured by Schleifer, as measured spectroscopically by Schleifer at low, were much faster than stars. In his concluding remarks, Curtis turned to Shapley and asked, quote, "Where do your spirals fit into your cosmic scheme?" End of quote. Curtis's question caught Shapley unprepared, but upon recovery, he answered, "I don't know what they are, but according to certain evidences, they are not outside of our galaxy." He then cited a certain supernova observed in Andromeda in 1885 with a brightness that would equal millions of stars, indeed, if outside the Milky Way. He then played his trump card, citing Van Manen's rapid spiral rotations to support his position. Curtis, aware that no one had been able to reproduce Van Manen's results, simply then smugly replied, quote, "There are some observations that are not worth a damn, and others that are not worth a damn. In my opinion, 2 dams are no better than 1 dam." At this remark, the room burst into laughter, and the newspaper reporters treated the laughter as a verdict. While the newspapers awarded a victory to Curtis, the astronomers in the audience remained divided. Some supporting Shapley's one big Milky Way universe, most of the others Curtis's many island universes. For one man in the audience, however, the very inconclusiveness of the debate was its most important outcome. George Ellery Hale saw this uncertainty as a compelling argument for more and better evidence and bigger and better telescopes and observations. Thus was born his dream for what would become some 28 years later, the 200-inch Hale telescope on Mount Palomar. But now, back to our story. Hale's largest telescope, the 100-inch Hooker at Mount Wilson, went into use in the same week as the arrival of his most famous hire, Edwin Hubble. Hubble had been recruited by Hale in early 1917 on the completion of his doctoral degrees from the University of Chicago and the Yerkes Observatory. But his arrival at Mount Wilson had been delayed for 2 years because Hubble had volunteered for an officer's commission in the Army when the U.S. entered World War I. He arrived at Mount Wilson on September 11, 1919, as, quote, Major Hubble, ready to study the universe with a brand new Hooker 100-inch Big Bertha of light. Hubble had earlier spent 3 years at Yerkes Observatory honing his observational skills using the 20-inch reflector that George Ritchie had built years earlier to compete with the Crossley at Lick. His Yerkes observations became the topic of his doctoral thesis, entitled Photographic Investigations of Faint Nebula. Hubble was very much aware of the controversy regarding the spiral nebula. After all, he had been a fascinated spectator at Vesto Slipher's 1914 presentation on the fantastic velocities of the spirals measured at the Lowell Observatory that I mentioned earlier. He later told Slipher, quote, "I was committed to one issue and one issue only, to determine the relation of the spiral nebula to the universe," end of quote. Exactly what Hale had hired him to do. After several sessions with a 60-inch telescope, Hubble got his first crack at the 100-inch Hooker, the largest telescope in the world at the time, which he called his magic mirror. On Christmas Eve of 1919, he spent his first year excuse me, he got his first crack at the 100-inch on Christmas Eve of 1919. He also spent his first year at Mount Wilson in an extensive study of the diffuse nebula in the Milky Way, but he also kept track of the non-galactic spirals that he came across. In February 1922, Hubble outlined an aggressive tech campaign on the non-galactic nebula, or the spiral nebula, studying their distribution across the heavens, their dimensions, their spectra. He knew that finding nova and variable stars would be a key metric in his work. By 1923, he had enough data to have devised a classification system for the nebula into ellipticals, spirals, or irregulars. Hubble's classification system, sometimes called the tuning fork chart, was eventually adopted by the astronomical community. He paid special attention to NGC 6822, or Barnard's Nebula, obtaining more than 50 photographs and discovering some 15 variable stars, of which 11 turned out to be Cepheids, he found out later. Using the Leavitt periodicity-luminosity relationship as calibrated by Shapley, he estimated the distance to it at 700,000 light years, well beyond the borders of Shapley's expanded Milky Way of 300,000 light years. This gave Hubble the confidence that he could use Cepheids as distant markers to the spiral nebula, and led him to the October surprise. On October 4th, 1923, Hubble concluded a night of observations under mediocre observing conditions with an exposure of M31, the Andromeda Nebula, which revealed a new speck of light in its cloudy veil, a suspected nova. From an exposure taken the next evening, Hubble confirmed not only one, but two additional pinpoints of light, and marked each with N for nova. Checking previous photos of Andromeda from the observatory files, he could easily see that the two spots were indeed new or probably nova, exploding stars. But one of them, the furthest from the center, had been around before, brightening and dimming over time. It was some kind of variable star. He went back to his plate and crossed out the N and wrote in bold letters VAR for variable. A copy of this historical photographic plate is now on display at the National Air and Space Museum. I saw it a few years back. Hubble had struck celestial pay dirt, and he focused on this find. He more carefully tracked the ups and downs of his variables luminosity, both from archival photographic plates and from additional measurements of his own. By February of 1924, Hubble had sufficient data to plot a reliable light curve, which identified the variable as a definite Cepheid, with a period of 31.415 days. He notified Shapley, who is now at Harvard, who immediately grasped that Hubble's findings spelled doom for his vision of the cosmos. Hubble had used Shapley's own calibration of Henrietta's period luminosity curve to calculate the distance to Andromeda, the most famous of the spiral nebula, of about 1 million light years, well outside of Shapley's Milky Way universe. Shapley, on receipt of this letter, was quoted as saying, quote, "Here is the letter that has destroyed my universe." Hubble's success spurred him to continue on his searches at a brisk pace, discovering even more Cepheid variables in both Andromeda and other spiral nebulae. By the close of 1924, Hubble, using the power of the 100-inch Hooker telescope and his newfound Sherlockian skills, had found a dozen Cepheids in Andromeda and 22 in M33, a space-on spiral in Triangulum, with periods ranging from 18 to 50 days. He accomplished this despite taking 3 months off for his honeymoon, which took time out for his observations. Although the news of Hubble's findings were spreading rapidly through the astronomy world, he was still reluctant to publish them into the scientific literature. He was hesitant to publicly challenge the results of his Mount Wilson colleague, Adrian von Manen, regarding his rotating spiral observations. Finally, Hubble succumbed to the urging of fellow astronomers, and at the very last minute submitted a paper to be presented at a joint meeting of the American Astronomical Society and American Association for the Advancement of Science. As noted at the beginning of this presentation, this paper, entitled Cepheids in Spiral Nebula, was read by Henry Norris Russell, a noted astronomer from Princeton, since Hubble was back in Mount Wilson, still hiding. Astronomers in the audience could practically feel the universe changing as they listened to the presentations. Hubble's data regarding the Cepheid distances was almost universally accepted, as Cepheids were fast becoming the gold standard for cosmic distances. And the 100-inch telescope had allowed Hubble to resolve the outer regions of Andromeda and M33 into vast collection of stars and not clouds of gas and dust. Hubble also hinted at more results yet to come, having cited variable stars in M81, M101, and NGC 2403 and other spiral nebula. For the astronomy community, the long and convoluted squabble on the nature of the spirals was over, and the universe became far larger and far more intriguing. Van Manen's results were discredited and to be ignored. The public was also caught up in this cosmic revelation, with the newspapers quoting, quote, Major Hubble as saying there is not just one universe, but countless whole worlds, each of them a mighty universe, strewn all over the sky. Headlines read, 10 million worlds in sky census, or gigantic telescope finds new wonders in heaven. Hubble was a hero, and the universe, as we now knew it, had been changed. From that day in January of 1925, the spiral nebulas became the sole subject of Hubble's professional life. He had an ongoing, vindictive 10-year campaign to discredit von Manen's findings, but now he was king of the hill at Mount Wilson, and his worldwide fame as the discoverer of the modern universe had inflated his already outsized ego. By 1928, seeking his next great challenge, Hubble embarked on a major program to see if there was a relationship between distance and redshift data, all of which equated to speed. He was responding to various models of the structure of the universe based on Einstein's new general theory of relativity. By 1929, he and Milton Humason had measured the distances and spectroscopic redshifts of some 24 galaxies, much of which data had been borrowed without credit from Vesto Slipher's earlier work. When he published these results in the Proceedings of the National Academy of Science, the results again shook up the astronomical world. These early results, which were later reinforced by many data points, revealed that the velocity of the galaxies was found to rise in a linear fashion as they were more distant from us. The slope of this line became known as the Hubble constant. These results seem to confirm the theory proposed in 1927 by Father George Lemaitre, a physicist and a Jesuit priest, that the universe was expanding, and conversely that it was smaller in the past, thus leading back to a Big Bang. The Big Bang name didn't come for about 20 more years. This confirmation contradicted Einstein's own view of the static universe, and he called this his biggest blunder, and opened a whole new chapter in the Annals of Science, because now we had indeed found the universe. And now I'd like to give you a musical finale. I think you'll all remember this song, so I'd like you to sing along if you can. This is not about Vincent van Gogh, as you can see. Lights. Starry, starry night, looking at the Milky Way, thinking it's so far away that it's impossible to comprehend. Well, upon the thought that galaxies shine from so far, we do not see them as they are, but as they were before this earth had been. We try to understand. Come on, sing along. The vastness of the universe, with measurements away, sometimes curse. 'Cause it's so hard for us to know how distant is a beam of light. Starry, starry night. Not so long ago, astronomers tried to explain theories that were on their brain about what the spiral nebula could be. Then with modernizing and instruments that measured well, they solved the mystery to tell the secret of the island galaxy. More Hubble than with the Hubble came along. Sorry about that. Found that blinking star to say Andromeda was far away, much farther than the Milky Way. That Cepheid is blinking still. I guess it always will. Thank you all.
Any questions?
Drawing in front of had that little scale like it was an engineering drawing on it. I wanted to interrupt you and talk a little bit more about that scale of that hand-drawn galaxy.
I'm trying to remember. I had several slides with
It
Andromeda
was a
on it.
black and white drawing and
The drawing?
the spiral, yeah, and it had a little scale on the bottom. I couldn't read. I wouldn't think it was astronomical units because we were talking about light years.
Yeah.
So it had.
No,
It
I
was
guess I can't respond. I don't remember one with a measuring stick on it.
There was a little, maybe some other people saw it.
The size of the Milky Way galaxy is about 100,000 light years across, and the Andromeda galaxy is about 200,000 light years across.
But that's not what I think he was talking about.
I thought that was.
No, just, yeah, with that scale, I'm personally, I'm getting more into math with just numbers and the universe and scales. So I'm interested in that scale and how he used that in that drawing.
Again, we could try to back up to that, but I'm not sure we have time. Do we? But go to the two more slides, if you would, please. Can you?
That one?
No, one more. Yeah, this is the book that I based my presentation on. It's a wonderful read. I suggest that any of you who have not read it might look at it, and it'll probably explain more clearly what you're talking about there. Any other questions? Well, thank you all.
All right, so
Thanks to my buddy Tom Hagan here, who brought me over here tonight.
Okay, so our next meeting is next week, Thursday, September 18th at Macomb Community College. Our next star party is Saturday, the 27th, the same day as the second day of astronomy at the beach. And several of us go to gastronomy after astronomy at the Redcoat Tavern, Woodward, north of 13 Mile. And with that, the meeting is over. Good night. See you later. Safe travels. Goodbye, Internet.
Good night.
Share. Shut down. Oh, chat. We had a chat. Great job.